In trigonometry, we'll be studying mostly about right angle triangles, and there is a remarkable property of right angle triangles that if I fix one angle of them, then no matter what the side length of the right angle triangle, the ratio of the side length is always the same. So let's suppose I consider a right angle triangle ABC, and in this right angle triangle, if I fix angle A and start increasing the lengths of AB, BC and AC, let's suppose this triangle is made, and then in first triangle, triangle ABC, if you find the different ratios AB upon AC, AB upon BC and so on, if you find all the ratios, then you will find out that the ratios are equal for triangle ABC and for triangle AB dash C dash. They will be same for both the triangles. So we can say that the ratios AB upon AC will be equals to AB dash upon AC dash, and AB upon BC will be equals to AB dash upon B dash C dash, and so on. All the ratios of both the triangles ABC and AB dash C dash will be equal. You can also try the same thing by fixing one angle of a right angle triangle and then making multiple triangles, and then by measuring the lengths of different sides, if you will calculate the different ratios, you will find that all the ratios for all the different triangles will be equal if you have kept the angle same. Now there are many ratios which we are getting in a single triangle, so it would be very confusing for us to study each and every ratio like this. So this was the same problem for the mathematicians also. So they did a smart thing. What did they do? They named each and every ratio and said those ratios to be trigonometric ratios, and we'll be studying these trigonometric ratios in today's video. So basically, since we have 6 ratios in all, so we have 6 names for the trigonometric ratios, and we'll be studying those 6 trigonometric ratios and understanding how to apply those 6 trigonometric ratios in any right angle triangle. So let's first see what are the names of these trigonometric ratios, and then we'll understand how to apply these ratios on different triangles. So first is sine, second is cosine, third is tangent, fourth is cotangent, fifth is secant, and sixth is cosecant. And since these are very big names, so mathematicians have shortened these names to sine is termed to sin, sine, and the shortened form of cosine is cos, tangent is tan, cotangent is cot, secant is sec, and cosecant is cosec. So we will be learning all the trigonometric ratios by their later names. So now let's understand all these 6 trigonometric ratios by using a right angle triangle. Let's consider our original triangle, triangle ABC, and try to understand the trigonometric ratios in this triangle. So now if I consider this triangle ABC, it is right angle at B. So can you tell me which side will be the hypotenuse? Hypotenuse is always the side opposite to the right angle. So since AB is the right angle, so the side opposite to AB will be AC. So we'll say that AC will be a hypotenuse. And there are 2 more terms which we should understand first in order to apply all the trigonometric ratios. These are adjacent and opposite. So to understand adjacent and opposite, first of all we should know which angle we are talking about. So in this case, we are talking about angle A. So if we are looking to angle A, we have to understand which side is opposite and which side is adjacent. So adjacent, as the name signifies, adjacent is the side which is near to the angle of consideration. Since angle A is being considered, so AB will be our adjacent and opposite will be the side which is opposite to the angle which is considered. Since we are considering angle A, so can you tell me which side is opposite to angle A? BC is opposite to angle A. So BC will be our opposite here, and these opposite and adjacent are also termed as opposite is said to be perpendicular and adjacent is said to be the base. So if we are given that base and perpendicular, so we'll say that the side which is near to the angle of consideration will be the base, and which is opposite to the angle of consideration is also known as perpendicular. Now to simplify these terms, hypotenuse, adjacent and opposite, we use H for hypotenuse, we use A for adjacent, and we use O for opposite. And to learn all the trigonometric ratios, there is a short trick which will remember to learn all the trigonometric ratios. So these trigonometric ratios are learned as SOH CAH TOA. What they are said as SOH, S-O-H, CAH, C-A-H, and TOA. You all have to remember is SOH CAH TOA. So let's understand what does this SOH CAH TOA mean. So says SOH. So SOH means S stands for sine, O stands for opposite, and H stands for hypotenuse. So we'll say that sine is opposite upon hypotenuse. The value of sine is opposite upon hypotenuse. Now let's move on to CAH. So if we take out CAH, CAH says that C stands for cos and A stands for adjacent and H stands for hypotenuse. So CAH says that cos is adjacent upon hypotenuse. Now let's move on to TOA. So if we take out TOA, T stands for tan, O stands for opposite, and A stands for adjacent. So TOA means tan is equals to opposite upon adjacent. So after you have remembered SOH CAH TOA, a next trigonometric ratio is cot. So cot is nothing but 1 upon tan. So all you have to remember is that cot is 1 upon tan. So cot will become adjacent upon opposite since it is 1 upon tan. So if we reciprocal tan, so it will become adjacent upon opposite. Our next trigonometric ratio is sec. Sec is nothing but 1 upon cos. So sec will become hypotenuse upon adjacent. So all you have to remember is that sec is 1 upon cos, and you have to reciprocal cos in terms to get sec. Our next trigonometric ratio is cosec. So cosec is reciprocal of sine. So all you have to do is reciprocal sine in order to get the value of cosec. So cosec will be equals to hypotenuse upon opposite. Now if you look at all the trigonometric ratios, SOH CAH TOA is for first 3 and next 3 are written in order such that the fourth is reciprocal of third, fifth is the reciprocal of second, and sixth is the reciprocal of first. So all you have to remember is SOH CAH TOA. So now let's understand this concept by using an example. So here is an example where we have to find the value of all the trigonometric ratios for angle A and angle C, and we are given the value of two sides, that is AC and AB. So we can find the value of third side. Since this is a right angle triangle, we can find the value of third side. How can we find the value of third side? By applying Pythagoras theorem. So let's apply Pythagoras theorem and find the value of third side. Pythagoras theorem will be hypotenuse square is equals to square of sum of other two sides. So it will be AC square equals to AB square plus BC square. Now put the values. AC will be 5, so this will be 5 square is equals to AB is 4 square plus BC square. Now if we find the value of BC square, this will go on the left hand side. So this will be 5 square will be 25 minus 4 square is 16. So this will come out to be 25 minus 16. And now if you solve, this will come out to be 9. And if you take the under root on both the sides, we'll get 3. So this will be BC is equals to 3. So we had also obtained the value of BC. So the value of BC is 3 centimeters. Now, since we have to find the value of all the trigonometric ratios and we have the sides, we have AC 5, we have AB 4, and we had calculated BC to be 3 centimeters. First of all, we have to know which side is hypotenuse, which side is opposite, and which side is adjacent to apply SOH CAH TOA. First of all, we have to know what is hypotenuse, what is adjacent, and what is opposite. Now, it is right angle at B, so AC, which is opposite to the right angle, will be our hypotenuse. So AC will be our hypotenuse, and for adjacent and opposite, we should first know which angle we are considering. So we are considering here angle A, this angle we are considering. So the angle which is near, the side which is near to this angle, which is AB, AB will be our adjacent, and the side which is opposite to this angle A, which is BC, so BC will be our opposite. Now we can apply SOH CAH TOA and get the values of all the trigonometric ratios. Let's apply SOH CAH TOA in all the trigonometric functions. A first trigonometric function will be sine of angle A, and if we apply SOH CAH TOA, first is SOH, which says that sine is opposite upon hypotenuse. Now if we look at the figure, our opposite is BC and hypotenuse is AC. So applying SOH, sine will be opposite upon hypotenuse, and opposite we can write as BC and hypotenuse is AC. So sine of A will be BC upon AC, and then we can put the values. BC is, we have found out to be 3 centimeters. So this will be 3 upon, and AC is 5. So this will come out to be 3 by 5. Now let's find out the value of cos A. Cos A will be equals to, what we will apply now? It will be CAH, the second term of SOH CAH TOA. So CAH says that cos is adjacent upon hypotenuse, that is A upon H. So if we look at the figure, adjacent is AB and hypotenuse is AC. So according to CAH, cos will be AB upon AC. So we can write down this to be AB upon AC, and then you have to put the values. So AB is 4 and AC is 5. So this will come out to be 4 by 5. Similarly, we can find the value of tan A. Tan A will be equals to, we can apply TOA here. TOA says that tan is opposite upon adjacent. So we'll look at opposite. The side which is opposite to angle A is BC and adjacent is AB. So according to TOA, our tan A will be BC upon AB. So we'll write down BC upon AB and put the values. BC we had found out to be 3 and AB was given to us as 4. So tan A comes out to be 3 by 4. Now if you see that tan A was opposite upon opposite upon adjacent by using TOA. So you can see that if you divide sin A and cos A, that is opposite upon hypotenuse, whole upon adjacent upon hypotenuse. So hypotenuse will cancel out and what will remain? Will get opposite upon adjacent. So the value of tan can also be found out by doing sin upon cos. You can either apply TOA or you can apply sin upon cos. In either ways we get the value for tan. Next is cot A. So we had learned that first three trigonometric functions are found out by using SOH CAH TOA and fourth function is just the reciprocal of third. So cot A is reciprocal of tan A. So this will be 1 upon tan A, or we can write this as adjacent upon opposite, or we can just reciprocal this will come out to be AB upon BC. We are doing reciprocal of the value of tan A, so this will be reciprocal of BC upon AB. So we have got AB upon BC. Now put the values, this will be 4 by 3. Now next thing is sec A, and sec A value has to be found out by doing reciprocal of cos A. So we'll do the reciprocal of cos A. This will be 1 upon cos A, and the value of this will be, the value of cos A was adjacent upon hypotenuse, so the value of sec A will be hypotenuse upon adjacent. So we'll reciprocal this will come out to be AC upon AB. Now put the values, this will be 5 by 4. Though you can directly do the reciprocal of 4 by 5 to get this. You don't have to do all this. You can directly do the reciprocal of what we have got for cos A and do the reciprocal of it and get the value of sec A. Next is cosec A. A sixth trigonometric function was the reciprocal of first trigonometric function. So to get the value of cosec A, we have to reciprocal sin A. So cosec A will be written as 1 upon sin A. Now to get its value, just reciprocal 3 by 5. So in terms of sides, we can write this to be AC upon, we are reciprocaling sin A. So this will be AC upon BC, and the value will come out to be 5 by 3. So this is how we had calculated all the trigonometric ratios for angle A. Now we have to calculate all the trigonometric ratios for angle C as well. So first of all, we should know the angle. So let's mark the angle here. This is angle C. So will the hypotenuse for this angle change? No. Hypotenuse is always the side which is opposite to the right angle. Since right angle is same, so hypotenuse will not change. But since our angle of consideration has changed, so adjacent and opposite will also change. Now AB will become our opposite. So AB is our opposite now, and BC will be our adjacent. So we had changed these two. This was adjacent before, now this is opposite, and BC was opposite before, now it is adjacent. You just have to remember that the angle of consideration has to be considered. So by using angle of consideration, you have to mark adjacent or opposite. Now since angle C is being considered, so we had marked opposite and adjacent according to angle C. Now we can apply SOH CAH TOA again for angle C and get all the trigonometric ratios for angle C. So let's write down first. First trigonometric ratio is sin C will be equals to. Sin C will be equals to, apply SOH CAH TOA here. So says that sine is opposite upon hypotenuse. So opposite has changed now. Opposite has become AB and hypotenuse is same. So we can write down sin C to be opposite. Opposite is AB upon AC. So its value comes out to be, put the values 4 by 5. Similarly, we can find out the value for cos C. Now when we are doing cos, so we have to take ka. Ka says that cos is adjacent upon hypotenuse. So adjacent is BC and hypotenuse is AC. So put the values, this will be BC upon AC, and if I put the value of BC, BC is 3 and AC is 5, so this will be 3 by 5. Similarly, we can find the value of tan C either by dividing sin C and cos C or by using TOA. So TOA says that tan is opposite upon adjacent. Opposite is AB and adjacent is BC. So this will be AB upon BC. Put the values, AB is 4 and BC is 3. You can try by dividing sin C and cos C and you will get the same value as TOA. Now we have to find the value of cot C. Cot C will be equals to reciprocal of tan C. So all you have to do is reciprocal of this value. Reciprocal of this value will be 4 by 3, reciprocal will be 3 by 4. So this will come out to be 3 by 4. Similarly, we can find the value of sec C. So this will be the reciprocal of cos C. So all you have to do is reciprocate this value. So this will come out to be 5 by 3. The reciprocal of 3 by 5 will be 5 by 3. A last trigonometric value is cosec C. So the value of cosec C we can find out by reciprocating sin C. So all you have to do is the reciprocal of sin C will be equals to cosec C. So all you have to do is do the reciprocal of this value, which is 4 by 5. So the reciprocal of 4 by 5 is 5 by 4. So the value of cosec C will be equals to 5 by 4. Now we have got all the values for trigonometric ratios for angle A and angle C. So what we have learned in this whole exercise is that if we have to proceed for any question, first of all we have to know which angle is being considered, and by knowing the angle of consideration we have to mark the adjacent, the opposite and hypotenuse, and when we have got the values for opposite, adjacent and hypotenuse, then we can easily apply SOH CAH TOA to find the values of all the trigonometric ratios.